Pick Computer Science video number 6. Again, the little man computer, and this time selection. Our instruction set, the new instruction we're going to use to be able to achieve selection, condition, the equivalent of if statements, is instruction number 8, or BRP, which is branch on positive. You'll see how that works in a moment. The machine code that's loaded up into the LMC is going to accept the input of two numbers by the user, and it's going to return the larger of the two numbers. So as part of that program, it needs to make a decision at some point. So we have our new instruction, our 8 instruction, our branch on positive instruction here. We'll see how all this works by stepping through it. The first thing that this program will do, as is the case with many of them that we've been looking at, is to get the user to enter a value. I'm going to input the number 67 first of all. Okay, and the next thing it will do is we'll go and store it in mailbox 11. So instruction 3 stores data, and it's going to store the value in the accumulator in mailbox 11. So 67 should go into mailbox 11. There it goes. And then we'll see something the same happening now for a second number, 78, and that should go into mailbox 12 by virtue of the instruction in mailbox 3. And there that goes. Now what will happen next is we'll go and get the instruction that's in mailbox 4, which is 211, and 2 is a subtraction, so it's going to subtract the value that's in mailbox 11, 67, from the value in the accumulator, 78. So we're going to do 78 to take away 67. So we should end up with 11 in the accumulator. There we go. Next instruction, mailbox number 5, is 808. So this is the 8, the branch on positive. And if the number in the accumulator is positive, it's going to jump to mailbox number 8 here. If it isn't, if the value is negative or possibly 0, then it will jump to mailbox number 6. Well, it won't jump at all, it'll just go to the next instruction, which is in mailbox number 6. But of course, the value in the accumulator is positive, so we are going to make that jump to mailbox number 8. And what that's going to do is it's going to output, so 5 is to load into the accumulator the value in mailbox 12, which is our larger number, 78. So the logic seems to work out. So let's just follow that through. We've jumped now to mailbox 8 because the value in the accumulator is positive. We're now popping 78 into the accumulator. Our next instruction is mailbox 9, which is just to output the value in the accumulator. So we output the larger of the two values. I've recompiled the program, and I'm going to cheat a little bit this time. I'm going to input my values into the handy little queue, this time the other way round. So 78 is going in first, so 78 should end up in mailbox 11, and 67 should end up in mailbox 12. And by virtue of doing that, we should end up not branching on positive here. So we shouldn't jump from here to mailbox 8. We should instead load up the value from mailbox 11, our larger number, which will be 78, and here jump to mailbox 9 to output the 78. So things should work and give the same answer as before. And I've got my inputs lined up. So let's just run this one with the animation on to see hopefully it working and giving the same answer as before, but working in a slightly different way. Our path will follow a different route. As we won't branch on positive, we should end up with a negative value. There we go. It's negative in the calculator there at the moment, so we will never branch on positive. We will just branch to mailbox 9 to output our correct answer 78. Success. As well as arithmetic, as well as iteration and selection, there are so many other things that can be done with a Little Man computer. And if you search on the web, you will find hundreds and hundreds of different resources and different problems to try and tackle with the Little Man computer, such as things like outputting all of the Fibonacci numbers, or using Euclid's algorithm. So ask your teacher, use the internet, and have lots of fun with the Little Man computer. Bye for now.